Welcome back. Previously, I recommend you to practice with this problem. And basically what I recommend you to do is to try Observer, Decorator. With Observer and Decorator, you can solve this, but I am going to use this same problem to move forward and review more patterns. We need to review at least one more in each category, and then we move to the next topic. So just to be sure that I can use this example, let's solve the example. Let me show you the solution for this, and you can compare whether or not the solution that I am going to show you match the one that you implemented. Your midterms, the graders, they are working. Hopefully they finish in 1 week. Next week, probably you're going to have notice about your grades. So moving forward, number one, if you remember, we talked about this idea of having one class creating random numbers. One class that is the source of the information for the position of these squares. Separation of concerns. If you're going to have several different functionalities in the software, one class, one responsibility, one class, one particular functionality, one collaboration with the system, one class, the responsibility, the random numbers. Obviously, the instructions in a particular method, in a particular class. If you review this class source, the only thing happening there, getters, setters, attributes, X and Y, and the method that do the work. And doing the work is creating the random numbers. Done. One responsibility in one class. Now, with the information that you have, that class is going to create information, is going to create numbers in this scenario. Something that we want is those numbers are going to be useful for other classes. We don't care which classes or what is going to happen with those numbers, but someone else is interested in the numbers. When you have that scenario, is this class is going to participate in an observer pattern. This class is going to be observable. If you are the developer doing this, in some point, these math randoms are going to become something else. Connection with a resource, a database, a cloud, a sensor, a device in the computer, whatever. In some point, you're going to need more methods, private method maybe, in order to collect the data, to parse the data, to generate the data. Your responsibility, but your connection with other classes is use the standard observer. And the thing that you need to do in this particular class, hopefully by now is clear. If I am going to be a class providing data to other classes, the only thing that I need to do is an extension. Whatever you want to use, the observer implementation in Java util or a listener for the property, if you want to move to Java beyond Java 9 and avoid the warning, up to you. But this one is observable. And what you need to do is every time that something important happens, send a notification. In particular, for the Java API, change and notify. This and this because the pattern, this and that because this is a source of information. Everything else is just the functionality of the class. Moving forward, another thing that you want to do is this data, these random numbers. You want to be creating random numbers in an infinite loop. Forever. Just like with the movement of the ghost in the Pac-Man. In the example, it's just numbers, 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 numbers to move this guy, the blue one, or to create a lot of yellow ones. Numbers forever. Numbers forever. Usually, if you are working in a program that is text-based, if you have a console interface, You can create an infinite loop, and that's it. Infinite loop, creating the numbers, you are done. If you are doing something that is graphic, it's a very bad idea to create infinite loops. Why? Because you have one loop running the graphical user interface. You want to have time to give the user the opportunity to make clicks. It's one thread. If you put an infinite loop, you are going to notice in your screen there is not enough time for the user to click things. You cannot move around. The clicks are not detected. When you have graphical user interfaces and you want loops, you need to think about threads, multi-threading, concurrency. We need to review in detail concurrency. But one easy way to implement concurrency that we used before, the timer. The timer, in particular, an easy way that you know. One class that extend timer task. The only thing that you are going to get is a class that, just like the ones that implement the listeners, are going to inherit a method, and you need to modify that method. The method is going to be that one. You're going to have that method run. And that method run is going to be executed every single period of time. Later, we're going to have the opportunity to define that period of time. But extending the class and whatever you put in this run method, again, is a method that you are getting from the inheritance. It's a method that you are overriding. Whatever you put there, you're going to have the opportunity to repeat that thing several times, controlled by the time. And the thing that I want to control is this. What I am doing, I am calling the other guy and I am asking the other guy to create numbers. Is this method create? In terms of software, what we have here is a delegation relationship. And that is the reason because I put the class boss, delegation. I need to do something, but I am going to delegate that responsibility in someone else. Here, if you think about the class diagram, what we are doing so far, we have this class source. And we use define source as observable. And we have this class boss. And that one, we define them like and I want you to notice that source, that is the class in which we are doing something, creating random numbers. But just by using inheritance, it's like, okay, and you are going to be also observed by other people. You are going to be sharing data with other classes. Boss, you are a timer task. Okay, you are going to be using concurrency. You are going to be running in parallel with other tasks, like the graphical user interface. And these two guys are connected. And the connection is this boss is calling a method in source. There is a connection there. And association. No, wait. It's an aggregation because the boss have this source, the employee, like a variable. Why? Because I am using in this method, the constructor. Someone is going to tell me who is my employee, but also I need that one in the rule. So I need the variable in two methods. I need the variable global. And so far, this is the design of the thing that I am showing you. One guy that is creating random numbers, observable, one guy that is able to run concurrently, and those two guys connected. The second one inside of the first one. Well, the point is, very good question. The point is this one. We do not really have the new here. So what happens if I send as a parameter here a null? Just because I have the possibility of source equal null, in that moment is aggregation, not composition. To have composition, you need to be 100% sure that that variable is going to have a value. And the only way to have that is if I put here the new. So the constructor run, I do the new, the variable have a value. But in this case, because it's a parameter, always, when you have the parameter, I do not know if the parameter can be null. It is possible. So if someone sends me a null, the variable do not have a value, aggregation. Good. So far, like my diagram, my classes, and as you notice, two people can be working here. One of you can do the balls, another can do the source. I know it's a very small program, but just think about increasing the complexity, at least the connections and the relationships. They are clear, use standard. Now, moving forward, if I have those guys, observable, I need an observer. Well, let's create an observer here. Oh, this guy is going to be working with the other. By now, you know that. And the only thing that is going to happen is, well, if I do this implement observer, my responsibility is to provide this update method. The update, what I do in the update, up to you, whatever you want to do. The only thing is, this update is going to give you access to whatever you are observing. What I am going to be observing? One of these guys, because the source is the one that you can observe, the note taker is the one that is going to be observing. And you can call methods because you're going to receive as a parameter the reference to the other guy. Okay, and the only thing that I am going to do, get the data, and with the data, store the data in a global variable. Why? Why do I need to store the data in a global variable? Well, you can do whatever you want to do with the data. You are observing, you are able to recover the data, in this case, the X. If you need that data in other method, put the data in a global variable, and the global variable, the goal is that several methods have access to that variable, right? Again, you need something in several methods, global variables. And you know what? This data, whatever it is, I am going to need it in different methods. Number one, I am receiving the data in the update method. The update receives the data. But the method that is going to use the data, in my example, is the paint component. Think about it. You know how to draw something on the screen. Paint component. Whatever you put in the paint component is something that you're going to draw. On the other hand, you know that your method update is the one that is going to be able to get access to the data in whatever you are observing. So one method needs the data, the other method have the data. A global variable, this one have the data, put the data in the global variable. This one needs the data, get the data from the global variable. The global variable becomes the bridge that connect both methods. Are you telling me that this is going to draw something on the screen? Yeah, it's going to draw something. In my example, I am going to draw string. I am going to draw a number on the screen. if I give you this method, can you tell me what to do here in order to draw this square? My example is drawing text, a string. What to do in order to draw this blue square, modifying this class? Two things that you need to change or add. If you're following, tell me, which are the two methods, the two things that I need to do in this class to have this blue square on the screen? One, I am calling get X. Hopefully you agree. I need to call also get Y, two numbers. Second, can we store those variables instead of in a string? Can you think about integers? Therefore, can you replace this string with something like that? Moreover, do you know what to do with those two X and Y's replacing this? If you're following with what I put in red and you know where to replace those in my class, we're moving forward. So this class is going to be able to read the two numbers and it's going to be able to print it on the screen. Yeah, obviously here you need to put the color in blue, whatever, but that is the only thing that you need. What I am telling you is now you have another class. That class is going to be able to draw things on the screen because of the paint method. But in order to draw things on the screen, you need to have access to the graphical elements. Yeah, we're going to have access. I am going to be a panel. That is something that we have been doing a lot. Inheritance. Okay, I am going to be also an observer. Observer. I cannot do inheritance. Observer is an interface, so realization. That is what I have. But the observer and the observable are connected. Yeah, they are connected. They are connected. I do not need to show the relationship between observer and observable because they are classes from the library. I know that there is a relationship from this one to this one, but in order to keep clean my diagram, I can avoid that one. But this one is calling a method, the getters. That one. And you remember the observer, the four classes, the connections, and the inheritance. That is what I have. Okay, so you have your source of information, you have the concurrency, and now you have your observer. Everything working. We need the main. Okay, the main. In another class, a different class, the main. For the main, the only thing that I need to do is create my objects. The objects, I am going to create them in the constructor. My method main, usually the only thing that do is create an object from the class, call the constructor, and then set visible, set size, and checking for the closing of the window. This is something that we have done several times. In the constructor, my object, the guy that is going to be creating the numbers. My object the guy that is going to be observing those numbers. My object, the boss that is going to have inside of the employee and is going to keep the things running several times per second. The boss is going to be connected with a timer, and the boss have inside the source, and the boss is going to be calling the create in the source forever. Every time that I call the create, that is going to be observed by this note taker that is inside of the graphical user interface, and that guy is going to be drawing things. Now, there are something here with the drawing things. Before reviewing this part, that part is the decoration, because so far what I have is already all the elements that are going to draw one rectangle on the screen. However, I want more. I want this shadow or these yellow ones. Those are decorations. The functionality is here. This one and this one, different levels of decoration, different extra things. Going back to my diagram, the only thing that I did was to add a main. The main, I do not have global variables, so I do not have diamonds, but my main is using this guy. My main is using one of these guys and one of these guys. That is what my main is doing, calling methods or using objects from the three things that I create. Good. This one, check. These two. Are you telling me that this shadow and these yellow things are decorations? Everything in the main, we already talked about it, except those lines from the 8 to the 13. Something called simple shape, something called the shadow shape, the cloud shape, and this is the guy that I have drawing things, the note taker. I am sending one parameter, one thing. However, this thing that I am sending is this one. And inside of that one, I put this one with an add. So I put something inside of this guy. And this one, the one with the shadow, this add, put something else inside. So when I send this as a parameter, what I am sending is that one with the other two inside, that one with the other two decorators. Do you remember the original object, decoration, decoration? That is what I have here. The original object and two decorators. And what I am doing with the adds, adding the decorators to the original one. And then I am sending that as a parameter to the note taker. The note taker. The one that is going to do the drawing. Are you sending a parameter? Yes, but you do not have a constructor here. I need to add a constructor. This thing is new. I need to complete my program. Remember, this one was drawing use a string. Or I can modify that one to draw the rectangle in blue. But now I have this idea of I want the shadows and I want the yellow ones, the decoration. For the decoration, I am sure that you remember that if you want to use a decorator pattern, well, you need to create something like a parent that is going to have two kids. One of the kids is going to have an extra relationship. And then if you want, you can create childs from the decorations. That is the shape that you remember for the pattern. 5 things. 5 things that I have on the screen. Some of them are up to your problem. Some of them are part of the pattern. This one, a parent from for the full family. I am going to call this one drawable. And maybe you remember that guy from previous examples. An abstract class. An abstract class used because, well, in my particular problem, I prefer to use abstract class instead of the interface because now I can put the variables there. I think X and Y is something that is going to be in all the family. Moreover, if I have the X and Y, I can have also the getters and the setters for the X and Y. In particular, I will use the setters. So setters, variables, and the draw method that you remember. The draw method for the drawable empty, I need to put the curly brackets, not the semicolon because it's an abstract class, but the draw is empty. I am not going to be creating objects from that one. It uses the parent of everything. The childs, the 2 childs for drawable. I have drawable here and I have drawable here. So looks like those 2 are the childs. Those 2, yeah, the simple one, the one that we used before. And the simple one is this idea of the element without decorations. What is the element without decorations? Well, the blue rectangle. The blue rectangle, yeah, I am going to put here the color blue. I am going to draw this rectangle in the coordinates X and Y, size 10. And why not? Let's print something on the console so we know that this is working. Just for that, we know that it's working. Even though I do not have anything on the screen, the error can be in any other place. Think about this like a logger. It's just things are happening. Things are moving forward. Which X and Y? I mean, I am using here these 2 variables, X and Y. Like, from where? I am inheriting those variables because this class is this one. I have the variables in the drawable. Wait, and what are you going to do to put values in those variables? I am going to use this setter and this setter. Where? Later, in another place. It is not my responsibility to put values there. My responsibility is using those values that I have in order to draw something, period. Someone else is going to put the values. And this one is the simple class. So my only responsibility is to draw the blue rectangle, nothing else. What about the other kid? The other kid is this class here, the other child, remember? And that one should be the inheritance, but also that one should have this diamond, the other drawable. If you remember, most of the code here is defined in the pattern. For instance, the thing that this guy should do here is to define the method, just like this one. But inside, the only thing is to call the method into the object that I have inside. That is my responsibility. As a decorator, the only thing that I am going to do is to pass the call to the method to the ones that I have inside, to the ones that are in these variables. That was part of the pattern. Moreover, if I have setters or getters, similar idea. a setter, a setter. I am going to do the setter. I am going to take the value, receive the value, and store the value. But I am going to pass the values also to the objects that I have inside. I mean, we all are going to draw something. We all need to have this information. This is the guy that is going to call the method for everyone. And also is going to share with them the values. Here, nothing in terms of functionality. Use following the pattern. And I am done with the parent and the two childs. Next, the childs of the decoration. The two guys that are going to draw the shadows and the yellow boxes. The kids of drawable decorate. Okay, one is going to draw this shadow in gray. The other is going to draw all the yellows. The one that is going to draw the gray, this one, what do we need? Well, if I am going to draw a shadow in a gray color, something that I need is the coordinates for the shadow. Think about this. You have the original object. The original object is going to draw the blue rectangle in the coordinates X and Y. That is the original. Then you're going to add a decoration, and that decoration is going to add the shadow in a different color, and the shadow is in a different coordinates X and Y. You need these variables, new variables. The variables. And your setters, your getters. As you can notice, setter for the all value and calling the parent. Remember, this calling the parent, this super, is something that the pattern asks you to do. Those supers is something that we previously did with all examples that we have run with decoration. The only thing new for us, these lines that are going to put values in our new variables. And I have the draw. And as you can imagine, the draw, gray color, we're going to draw the shadow, right? My only responsibility here is to draw the shadow, nothing else. The shadow, in which coordinates? In my global variables, this all X, all Y. The gray rectangle in the new coordinates, same size, and also a message to the console just to be sure that this is working. And at the end, just like with the other method, super, super, super. That is something that the pattern asks me to do. Why? Because I am going to draw the shadow. I am going to call the parent. The parent is going to call the other decorations that I could have. So if we have also the yellows, that super is the one that is going to continue the calling to draw the blue, this gray, and the yellows. Separation of concerns. I have the gray, I have the blue. You can imagine the other child, this one, the one drawing the yellow things. If you compare this one with this one, you can notice that they are kind of the same. Setters, similar idea. The only reason because I have different methods is because there, the shadow is gray and it's only one. It's only one. I only have one more X, one more Y. For the yellow ones, I ask you to draw every single place, a rectangle in yellow, in which the rectangle have been before. Something that this guy needs to do is to store all the X and Y coordinates that we have read before. And in order to store all of them, I do not need only one more variable. I need two data structures, one list of X, one list of Y's. And if I have this list, the setters and the getters are not going to be like the previous one with one equal, but the setters and the getters are going to be adding, add, because we want to keep a track of every single value that we have saw before. And for the draw, super at the end, as usual. But now my draw is in yellow, the draw the rectangle, but now inside of a for loop. Why inside of a for loop? Because I want to draw every single X and Y coordinate that I have stored in my list. Did you notice the decorator that is taking care of the yellow rectangle? Everything in one class, the variables, the method, the actions. The class that is taking care of the shadows, everything in one single class, the rectangle in gray, the shadow in one place. The class that is taking care of the rectangle in blue, the original one, in another class. 1, 2, 3 classes, the original, decoration 1, decoration 2. And in order to assemble the pattern, the parent from the decorators and the parent to the full category of class. Okay, so that is the source code. But now you are telling me that in a class diagram, you have this class here, and that one have inheritance to two classes, which have inheritance to two classes, and this one is the blue rectangle, and this one is the shadow, and this one is a bunch of rectangles in yellow. And this one have a relationship like that. And the problem is now what I do in order to connect this red part with the blue part that I have above. Number one, something that we already did is in the main. In the main, something that I did was I create one of these. And in the main, I create one of these. And in the main, I create one of these. In the main, I create those three elements. Moreover, I create those three elements and I put them together. I am talking about this part. The main with the decorator, I create one original object, two decorations, and I assemble them, calling the add. Then I am sending whatever I create as a parameter. As a parameter to this class node taker. So to the constructor of node taker. One object in here, one object here, one object here, and then, oh, this relationship with the node taker is already there. What should I do in the source code of node taker in order to have, instead of this, use the decorator? Because it's the only thing that I need to do. I already created a decoration in the main. The only thing that I need to do in order to move from whatever I have here to one idea like this is to change this class. what do I need to change? Do I need to change the update method? Anything in the update method that I need to change? Well, besides the fact that I need to call get Y. It's like, no, your update method, if you call get X, get Y, it's going to be the same. Okay. Do I need to change the constructor? In fact, here I do not have a constructor. Do I need to add a variable, maybe a global variable? And that is going to change my source code, but also my diagram. Do I need to change the paint component? Maybe. Source code for not taker. Public class, no taker, and this guy is extending JPanel. That guy is implementing observer. Okay, I need a constructor. I need a constructor because in the main, someone is calling the constructor for node taker. And is sending a parameter. So far, right now, this guy cannot receive that parameter. In order to receive the parameter in the constructor, I need here a constructor. A constructor that receives a parameter. Help me, what is going to be the data type for the parameter? What did we send as a parameter? And what can we use here as a data type for the parameter? Well, we are connecting this guy with what we create with decorations, right? What we're going to send here as a parameter is one of the elements without decoration or one element decorated. Good news, both have the same parent. We can use here as a parameter, the data type for the parameter, the top of the family. If we do this, I can pass one element without decorations, or I can pass the element with as many decorations as I want. The parent, the drawable. And what I am going to do with this P? In the constructor, nothing. This guy, I am going to need this guy later in the paint component method. The paint component is the method that do the work. In that place, I need this guy. So I have a variable in one method, but I really need that variable in another method. So there are two methods that need the variable. One in order to modify the value, the other in order to call the method because that variable is an object. What do? A global variable. Two methods need the variable need to be global. Global variable. Whatever name. The only thing that the constructor is going to do is to receive the parameter and store the parameters in the global variable. Done. Nothing else to do in the constructor. Remember, separation of concerns and independency. This constructor is doing his work. Receive a parameter, store the parameter, use the parameter to provide a value to a variable. Done. Nothing else. Okay. My constructor, my variable. Next. The update, because I am an observer. In the update, we already defined that. The only thing that this method update should do I need values for the variables X and Y. And those variables, I am going to get the values calling my getters methods. My getters from where? From this object that I am receiving as a parameter. Yeah, you need to do the casting, but at the end is get X, get Y from this object. And you're going to get the values for X and Y, the new values for X and Y. What are you going to do with them? Store them in a global variable, because you need those values in a different method. One variable, the connection with the decorator. Two variables, the integer values. This method, put one. This method is giving you the others. The last one, the important one. The important thing that should happen here with this note taker is that I am a panel. And because I am a panel, I have the possibility of drawing things. And I have that possibility because I have this parameter. Important thing, you are extending panel. You are going to override this paint component. And this paint component, whoever is going to call paint component is going to give you this parameter, the access to the screen, the access to draw things. Okay. What do we do in the paint component? The paint component is the one that somehow need to work with this decoration. The paint component have one object from this class, and that class is the parent of everything. Which methods do you have in this class? Two setters and one draw. So you have this setter and this setter and this draw. The setter, integer, the setter, an integer, and the draw, and you're expecting this graphic. I have the graphics. I can call draw and check the graphic. These setters are expecting X and Y. I have the X and the Y that are the ones that I get from the thing that I am observing. I can use these ones. This one is the parameter, and the other two, my globals. Where are those methods? Those methods are the ones that I have in a drawable, in an object drawable. I have one object drawable, and I receive that one as a parameter. I do not create that one. Someone give me that one as a parameter. I can use it. Done. Really? That one is going to draw this one? Yes. or this one, or this one. Done. That is the only thing that I need to do in the note-taker class. And I need that note-taker class, and I need these classes. And the configuration about if I want the yellows or the shadow in gray or only alone the blue one is this configuration here. You only want the original, send the original object. You want decorations, add the decorations, create the decorations, add one or both, and the result is going to be what you saw in my screen. Done. Observer, concurrency, decoration, separation of concerns, the two patterns, working and connected. And the class diagram, more or less, the one that I described to you before. One thing, I have this part in red and I have this part in blue. I think somehow we need to connect the red and the blue. I am missing some lines. Can you help me? Which lines I am missing? Association, composition, realization, and between which classes? I think in some point we have a diamond. There is a diamond between drawable, and I think there is some class that have inside a drawable. And if you follow everything that we did before, you will agree that line in yellow, note taker, a diamond with drawable. And the diamond is white just because we are sending the drawable as a parameter. Therefore, we do not have the security that is going to be not null. So white diamond, because we cannot assure that it's going to be black. That is the connection. Everything else, the connection with the main that we already described, this main is doing one of these, the main is doing one of these, and the main is doing one of these. Assembly everything, pass a parameter, the assembly object to the note taker. The note taker is going to store as a global variable the diamond, and it's going to call the methods. Done. Decorator in red, observer in blue, and also in blue, the concurrency, class diagram, the source code. My request for you guys, hopefully you did this before your exam. If not, I am giving you the source code, I am giving you the class diagram as a homework. Review this, the video, the slides. You have the source code, and well, I shared with you this class diagram from a different lecture, but more or less what I described before, the source code, some notes, and some boxes. Be sure that it's clear. Because now, if I want to increase things here, if I want to increase the complexity or the functionality, hopefully we get the idea that I can create another functionality with another pattern, and the only thing that I need to be concerned is how to connect that new thing that I create with another pattern, and hopefully with one class or a minimum number of classes with what I already have, or another. And what you have with the classes and the patterns is the possibility to create this integration of functionalities in your software with the minimum number of connections, or at least with connections that you know from the beginning what are you going to do for the integration. So separate the work in a team project, for instance. That is the goal, separation of responsibilities. Anyway, hopefully all this is clear. Just to be sure that you have the knowledge about how to solve the problem that I mentioned before. Clear? Any questions? Nothing. Good. So moving forward, we cover this guy, and we cover this guy. Something that I want to do quickly in the next 15 minutes is we need one pattern, at least one, in our collection from the creational category. So the easiest pattern in the world, Singleton, is the easiest one in all the 23 that I am showing you the names here. And we're going to review that in order to have at least the knowledge of one pattern in each category. The Singleton pattern, easy. The Singleton, if you need in your system one and only one object from a particular class, there is a particular class, whatever is that class, and you want to be sure that one and only one object exists from that class in your full system, the solution, the Singleton pattern. I am sure that if I ask you what you can do in order to have a class and be sure that whatever happened, however the number of programmers you have, there is going to be always only one object from that particular class, you can start thinking about several different solutions. Counters, if, else, validation. The solutions are several and diverse. One of those solutions, one solution that works and usually the people use, is the one proposed by the Singleton pattern. What is that solution? Well, very simple. Usually, if you have a class, you can create as many objects as you want. Why? Because the only thing that you need in order to create a new object from that class is to use the operator new. Do you remember what happened every time that you use the new? Every time that you use the new, the constructor of the class is called. So every single time that you need a new object or an object from a particular class, you use the new operator. However, you cannot use the new operator if you do not have a constructor, because the new basically is calling the constructor. And in order to be able to call the constructor, all your constructors are public. So you can create an object from any class, calling that constructor from any other place, any other class. If you only want to have one object, you want to limit the number of times that the new is called. You cannot limit the new, but you can limit the constructor. How? That is the pattern. The first time that we are not using inheritance, the first time that one pattern is used, one single class. Can you notice what is happening in this diagram? One important thing that we have here, maybe the most important. Did you notice something here that is different from what we usually have? Element number one, the most important thing in the Singleton. Remember, the name of the class can be whatever. We call the class Singleton in the template just to give you a name. It's like the empty space in which you can put whatever name you want. Did you notice what I am pointing with this arrow here? What is that? A private constructor. Agree. The minus is private. And Singleton is the name of the class, is the constructor of the class. A constructor private. It's the first time, probably, in your programming experience in which someone is telling you, put a constructor private, because that was against everything that you review in your 110 class. Your constructors are public because what you want to do is to do this, create several different objects. Public constructor in order to use the new, in order to create the objects. What happens when you do the constructor of the class private? I am going to be able to call the new and the constructor. I am going to be able to do b equal new b in the main. When you put the constructor private, that didn't work. And you're going to receive a compilation error. When you put the constructor private, what you are doing is from that class, B, you cannot create objects. 0 objects. No one can create objects outside of the class because the constructor is private. Okay, that is fine. At least we are not going to have these several objects. The problem is now we have 0 and we are looking for 1. We need a public method. A public method, whatever name you want to use. Usually it's going to get to be something like get, whatever name you want to use, that is common. That one is going to be public, so I can use that one outside. That one is a getter. It's going to return something in particular. It's going to return an object from this class. It's the same thing that the constructor do, but this one is not the constructor. The constructor is private. The constructor is canceled. This one is a common method, but it's going to be able to return an object from the class. An object from the class. And here we can check that every single time that you ask me for an object from the class, I can check that it's only 1. And I am going to check that it's only 1 using a condition. An if condition. In particular, what I am going to check? Well, you know what? I am going to have a global variable in the class. The global variable is going to be a global variable that is an object from the same class. An object, whatever name you want to use. If that global variable is null, is empty, what I am going to do is to create the object, and the object is going to be stored in that variable. Wait, you are using the constructor, but the constructor is private. Can I call the constructor here, even though it's private? And hopefully you agree with me, yes, because you're calling the constructor inside of the class. When something is private, it's private for the other classes. But inside of the class, you can use the method. My constructor is private, but I can do news in another method that is also in the class. If the object is null, I create the object, but only when the object is null. If the object is not null, if this condition is false, I do nothing. And at the end, I need to return something. I am going to return the object. Every single time in any class in which you need an object from this class, what you are going to do is to call this method. Because if you call the constructor, you are going to receive a compilation error. And that method is going to return to you one object from the class. If the object already exists, it's just going to return the object. If the object does not exist, it's going to create one and then return to you. Okay, now I have a problem because in order to call the method, I need something there. I need an object, but I cannot create an object because the constructor is private. What other thing I can use if I cannot create an object in order to call the method? Exactly. What I can use is the name of the class. And in order to use the name of the class, I need this method here to be public static Singleton get instance. It's a static method. Name of the class, name of the method, and what I get as a result is something like, well, if you want an object, Singleton as, instead of calling new, whatever, because it's going to fail, what you are going to call is the name of the class. That do not need to be Singleton, could be whatever, but well, Singleton, and your method. And that method is the one that is going to give me a value for my variable. And now that I have access to the object, I can call the other methods or use the variables or whatever that object has. And just because this source code here, always, 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 only one object from that class. And the object is encapsulated inside of the class. One more thing. If this method is static and the method is static and it's going to return this guy here, what I need to do in this variable in order to be able to use that variable in a static method. In order to use a variable in a static method, that variable needs to be static, right? So, summary. You want a class, and that class is going to create only one object, always. Your class, number one, constructor private. So with that, no one can create object from your class. Second, your class, a public method that is going to be static, that is going to return an object from the class, that is going to have always an if-else condition. If else, it's going to check if a variable that I have global is equal to null or not. If the variable is null, it's going to create an object and store the object in that variable. If it's not null, the only thing to do is to return that object. That object, because I want to return that object from a static method, that variable, the global one, should be also static. So what you're going to have is a diagram for the pattern that looks like this, plus the fact that this one is static and this one is also static. The method public, the variable private, and the constructor, notice private. Those are the three features for the Singleton pattern. Any question, guys, so far? Okay, I am going to stop here. Please, homework. Review the source code that I shared with you, review the class diagram, and take a look at this. We continue with the source code for the Singleton, an example next lecture. Thank you.